So, welcome to Intro to Python. This is the week 3 lecture for Computer Science 1023 Digital Culture. So, today we're going to start talking about programming. Yay! It's my favorite part of the class. So, what is programming? Just a program is going to be a set of instructions. We feed it into the computer processes it in some way and then gives you an output. It completes the task and it gives you some output of the result. That's all it is in the most basic, simplest, definitions. You can write programs in lots of different languages. There are a lot of different programming languages that were kind of made for different purposes. They are best suited for different things. In this class, we are going to write programs using Python. Python is a really nice introductory language, and I'll talk more about it on the next slide. So whenever we write a program in Python, it's just going to be some text, and it will be in a file that will have a .py extension. So you might be familiar with extensions like .pdf, or like .doc for a Word document, JPEG for a picture. Here we're going to have a .py extension to tell the computer that it is a Python file. So that's how the computer knows that when it goes through and reads that information, it is supposed to go through and process it as Python instructions. What is Python? What is this language? It's been around for a while. It was invented in the late 1980s. This hyperlink takes you to the bio of the developer. He's still around. It's really kind of crazy to think, truly just a living legend because Python is such a big name. It's such a popular language. And the fact that the person who created it from scratch did so 40 years ago is kind of wild. It is a general purpose language. So, what that means is that some programming languages are written for kind of a specific purpose. So, one that is used for websites, or one that is, best used for formulas and scientific calculations. Python is a general purpose language, which means it can be used well for lots of different applications. It is a high level language, which means that it is written more like what humans understand compared to written to what is easier for computers to understand. So a high level language is going to be one where the commands kind of sound like English. They kind of make sense to us. They will use words like print or if or while, and those words are things that we are somewhat familiar with and have seen before. The main goal of Python, the whole kind of idea behind it, is that it had very simple syntax. And the syntax of a programming language is kind of like the grammar that we have in our normal languages. So, for example, grammar in English, you might end a sentence with a period. You might, have quotation marks around direct quotes. Those sort of rules that you learn for how you can properly read and write in that language. Programming languages have grammar rules as well, and we call them syntax. And so Python was made to be really easy to read and write because it has very minimal syntax rules. And that's one of the reasons that it's a really nice language for beginners to learn. It has a dynamic type system. We're going to talk a little bit more about data types in just a second, but a type tells the computer what type of information is being stored in this variable in your program. So you could store information of different types. Maybe you have numerical data that you want to be able to do mathematical operations on. Maybe you have text data that you want to be able to format in different ways. So you kind of, need to tell the computer what kind of information it is working with so it knows what kinds of operations are valid to do on that data. Python is really nice because dynamic means it happens during runtime. It kind of happens like as the program is executing. Python can go through and determine what type of information you need for this variable itself. So, some languages like Java or C++, you have to tell the computer the data type every single time you make a variable. Python can go through and determine the data type itself as the code is running, which is really nice. And this right here is really the main reason that Python has exploded and become as popular as it is. It has a very large, comprehensive library. There are so many different packages available that you can bring in to Python. So it is general purpose, but you could bring in a library is going to be a set of commands that all kind of perform a specific task. So I could bring in a library and allow my program to have lots of different commands to perform some of those more specific tasks, even though Python can be used for lots of different things. It is an interpreted language, which is kind of neat. It goes through and runs every instruction one at a time, and you can even type your instructions directly into the command line and run them without even having to write it in a text editor. Okay, what do I mean by a text editor? So, a program is literally just text. That's all that it is. It is just you write text. You can do it on anything. You can write programs on your cell phone. There is nothing difficult or special about it. You just need the ability to write text. However, if you want to be able to actually go through and run the code, you need to have a programming environment. And when you set up the programming environment, the computer would have to have downloaded the language that you are working in, and then some way that it can go through and interpret those instructions. So you need, a compiler for some languages, or you need, your environment has to have those libraries available so it knows, how to go get them. You kind of have to go through and do a little bit of overhead to get it running. So the question is, how are you going to be able to write programs for this class? And the easiest thing to do would be to use an online environment because then you don't have to download and install it yourself. You don't have to worry about downloading Python and also downloading some place to write your code and going through and like setting up the environment. Whenever you use an online development environment, that's all just set up for you. And one other thing that's really nice about a web based environment is that it will run on different devices. So, if you wanted to download and set up your environment locally on your own machine, you absolutely can. And that's kind of nice because then you don't have the internet, you don't have to have the internet to run it. But those things can behave a little bit differently if you're working on a Windows machine or a Mac or different operating systems. So, one thing that's nice about using an online environment is it's just a website and it works the same for everybody. For my examples in class, I am going to use an environment this semester. This is brand new that I created for this class, and I'll show it to you a little bit later in this video. It's called Glide, and it is online and web-based. It does not have some of the features that some other online environments will have. Um, some of the things that would be a little more like in depth or heavy duty, like it doesn't have a debugger, which a more kind of professional IDE would. But it does have a lot of the commands that you will need for class already created and built in for you over on the left-hand side, where you can just go through and click them, and it will insert some code for you that you can go in and edit yourself. So the whole idea behind it is that it was specifically created for beginners. So if you have some programming experience and if you are comfortable downloading and setting something up yourself, or if you already have a Replit account, or you are more familiar with some of these existing options, that is great. By all means, use whatever you are comfortable with to write your code. If you have no programming experience at all, I think that it could be helpful to try to use this environment that was kind of just more simple and has a little bit of those built-in supports for beginners. And this is hyperlinked. Every one of these is hyperlinked. So you could click on those to go to those places to create your accounts or to download it. And if you need help getting your environment set up and running on your computer, then you could, come into my office hours and I'll help you with that. Okay. So now, what are some of the commands that we can write? What are some of the things that we can do? So this is an example of just a first program. And usually when someone is learning a new programming language, we tend to start with the simple and basic hello world. So here we have one command. It's just the word print. You can guess what it does, exactly what it sounds like. It is going to not print something out like from a printer. It will print it to your screen. So what the word print means is it's going to display over here in our output console. Okay, so it'll print to the console. You'll see it on your computer screen. And then the way this command is working is everything inside the parentheses is what's going to be part of that print command. And in this example, all we have done is give it some text inside of quotation marks. And so whenever you have text inside of quotes, we're going to call that a string. A string is going to be just a set of text. It could be a sentence, a word, a paragraph, one single character. It doesn't matter, just any text. And if I have quotation marks around it, then it is going to print out exactly what is in the quotes. So here we have an example. There's one command down here, print hello world. And then you can see over here the output of that. Okay. What kinds of things can we put inside of our Python programs? So we might have some commands like that print command that we just saw. So those would be reserved words. Those are special words in the language that have meaning. And the computer knows that when it sees this word, it is supposed to follow the instructions. It knows what to do to print. It knows what to do if it sees the word if. It knows what to do if it sees the word while. Those are reserved words that have special meaning. We could also go through and write some sort of programming statements. So we'll see an example of that on the next slide. I can hard code in data, so I can just use like the number 7 or, negative 3.4. I can just type in the literal values that I want to use and work with. I can also take some information and store it in memory. So when we do that, it's called creating a variable. A variable is going to say, I'm going to give you a name. Every time I use this name, I want you to go to that place in memory and use whatever information is stored inside of it. And the value that we store inside of variables can change over time. I'm going to pull up some examples and work with them and show them to you in just a minute. Our program can also do math. We can ask it to do some mathematical operations. And they can also contain something called comments. And I'm going to back up just a second here, because in this example of code, Here, I have three different things going on. Over here on the left-hand side, I have that toolbox that I mentioned before. So these are just some different Python commands that I could kind of plug into my code and see what they do. But here in the middle, I have my workspace. And this is kind of where I'm going to actually type my Python program. And I told you that there was only one command because we have this print statement here. But up above the print statement, you'll see there are some other lines of code. It's kind of a different color. And it says, welcome to Glide, try snippets from the left or type your own code, click run. You'll notice that we don't see that printed over here in the output. Like I hit run and I saw hello world, but I don't see any of this up here. That is because these are comments. The way you can tell it's a comment is because it has this hashtag right in front of it. And in Python, that hashtag is going to be a single line comment. And a comment is going to be ignored by the computer. You write them for the sake of the programmer. You write them to make notes to yourself or to other people that might go through and read your code. They are used to put your heading at the top of a program that you're going to turn in for class. They are used to explain what a piece of code is doing or why you wrote it that way. You know, maybe you tried it one way and you kept getting a funky error. And so you had to change it and do it this other certain way. You would like to be able to leave a note about that to yourself. So 2 weeks later, when you pull your code up and you're like, why did I write it that way? You know, that's funky. You can read that little note and be like, oh, yeah, I'm forgetting that error. So it's really easy to forget things like that. It's nice to have good comments to go back and kind of help explain things and remind yourself later what's going on. And these are just kind of a list of some of those reserved words in Python. These are some of those commands. And maybe not every single one of them is a word that you would be familiar with, but a lot of them are words that we do recognize from English. So it's kind of nice that Python uses words that we are familiar with and we can kind of, figure out what a lot of these would do just based on recognizing what the word is. Okay. So here let's talk about variables. A variable is just you have some piece of information and you want the computer to be able to keep track of that information as, you go through and do something with it throughout your code. So it's some place in memory that is reserved for you to store data. It has a data type and a name. So every time you use its name in your program, the computer goes and gets that piece of information. And the value can be changed or overwritten over time. So here's an example. Here's that print command that we saw before. Print 1. This is just a hard-coded, literally the number 1. So the computer would just print out a 1. But here, we took the number 2 and we stored it inside of a variable called x. So what this equal sign is doing in Python, we are going to call this equal sign the assignment operator. And what it says is go through and do whatever is over here on the right and then store it at this location over here on the left. You cannot switch the order. If we had said 2 equals x, that would have been an error. It would not even run. So it has to be value, location. So what this did is it kind of just created some place. So we said, okay, computer, go give me a box, go reserve some little spot just for me, and I'm going to call it X. And so every time I refer to something called X, I want you to go to this little box and I want you to grab whatever's inside of it. And at this moment in time, the little box happens to have a 2 inside of it, because that's the value that we put in here right now. And so I could print out X and it would print out 2. However, we could change the value in X if we wanted to. So I'm just going to clear all of this out. I could change the value inside of X if I wanted to. And sorry, I'm just going to clear everything. And it would go through and it would give me whatever value was inside of X as it changed. So here's what I mean by that. Here I've created a variable and I'm going to put in the value 3. And then I'm going to ask the computer to just print out whatever is inside of X. And you might see like there's some little color coding going on here. So the programming environment that you work in will try to give you some hints about things, about different things that you have written in your code. So here in this example, do you see how the X has kind of been color coded? Hey, this is a variable. And then my value has kind of been color coded as well. Hey, this is some like primitive value that you've given it. And when we asked the computer to print it out, it did not print out the letter X, it printed out the number 3. And that's kind of interesting because earlier we asked it to print hello world and it printed out hello world. But this time we asked it to print out X and it did not print out X. So the question is, what's the difference, right? Why did it not print out literally the X? So I'm going to come over here to this toolbox and in my basics category, I just sort of have a print statement built in here. And if you take a look at this print hello world, and so we'll run it here. So I'm going to clear and I'm going to run. So you can see I have 2 print statements. I have a print statement right here on line 2, and I have a print statement right here on line 4. And here it printed out exactly what was inside this print statement. But up here, when I asked it to print out X, it did not. So just take a look at these 2 statements and see if you can kind of just spot the difference. Why is it doing 2 different things with these commands? Hopefully you saw that the big difference here is the quotation marks. Down here inside of my string of text, what is inside the quotes is my literal, my string literal. That's going to be exactly what gets printed. Up here, I don't have quotes around that. I'm not telling the computer to use a string that has an X inside of it. I'm telling the computer this is a variable name, and I want you to go find that little box that you made for me in memory, and I want you to get whatever information is inside of it. If I did come up here and put quotes around that X, and then I'm going to clear this and run it again. Now I'm literally telling the computer, go print out the letter X, right? And so we can see that in our output. It's been changed. Now, let's say, sorry. Variables don't have to be called X. I'm just doing that as just like a short, easy example. You can name your variables almost anything you want. There are a few rules about it. Let's see if I have it in the slides. I do not. So we're going to add that into the slides and I will update it because there are 4 rules about what makes a valid variable name. And you do need to know that for quiz 1, hint, hint, wink, wink. So we can create a variable here and we can name it just about whatever we want. It cannot be one of those reserved words, right? I can't name a variable print. That would be very confusing for the computer. How would it know if I was trying to go use that piece of information that I made for it, or if I wanted to actually go do the print command, right? It wouldn't know the difference. So you cannot name a variable a reserved word. It also has to be all one word. So let's take a look at that. Here's an example of a variable, just some other name. Here is a variable that is literally called name. There we go. Here is a variable that has more than one word. So let's say like a really big number. I don't know. Sure, whatever. Even though I wanted my variable name to be multiple words, I could not actually have blank spaces in them. If I wanted to run this, so maybe we ask the computer to go through and print out name. This is, I'll clear it. This is fine. This worked great. No problem. If I tried to go in here and separate this out, and I wanted to try to call my variable a really big number, and I try to run this now, I get all these error messages, right? It didn't work. And it's telling you, it's actually a pretty good error message because it's telling you right here on line 3. So here we are on line 3. That's where the problem is. It says on line 3, I don't know what's up with this second word. I'm aware that the word a is a variable name. I get that. I don't know what really is. So it only kind of knows, it only kind of understands how to interpret a variable name as one piece of information. The other way, and I'm just going to delete that because I don't want to go back and redo the typing for it. The other thing we have to be careful of is that we cannot have really funky characters in our name. So our variable name can have capital letters, lowercase letters, digits 0 through 9, and it can have underscores, but we can't have like funky characters. So if I try to throw like some different random symbols in here, and I try to run that, I get another error message. And actually, let me just clear all of this. So we will just see the error message that we got right now. And here it is. It says on line 1, we are angry about line 1. It says, I don't know. See the little caret where it's showing me this is where the problem is? It says, I don't know what's up with that. Okay, I don't know what to do with that because it is an invalid character. So our variable names cannot be reserved words, have to be one word, cannot have funky characters, and they cannot start with a number. Like they have to start with a letter. So here, like I have a number, I have num1, and that's, oh, let me just click that out so you can see. That's fine. It ran, no problem. But if I tried to call it, if I tried to call it one num, like if I tried to make it start with that digit, I get an error message and it doesn't understand what to do there. So those are our 4 rules. I will go back and add them into the slides. We need to start with a letter, no funky characters, all one word, no reserved words. Okay. So let's clear all of that. And then let's go through, let's show that the value that you store inside of a variable can be changed and overwritten, and that's okay. So let's say I'm going to ask the computer to make a variable. So here is an example. It created x equals 42. I could print that out. I see a 42. Even though this is saying variable over here, I don't see that in my output because that is a comment. How do I know that it's a comment? It's got that pound sign, that hashtag. And you can also, there's a little bit of color coding for the comments as well. It's kind of gray. It's very subtle. It's maybe a little hard to tell the difference. But this is just a little comment letting you know what's happening. It's not actually part of our output in any way. So then what if I ask the computer to change that value? So maybe I say, maybe I come down here and now I want X to equal 12. And then I print the value in X again. So I'm going to clear this, run it. When the computer got to this print command, so the computer is kind of going to go through and read our program like we read a book. It's going to go top to bottom, left to right. So it starts here. The very first thing it does, makes that box, puts a 12 inside of it. When we print out puts a 42 inside of it. Whenever we print out the value in X at this moment, it prints out the 42. Later, 2 lines down, we tell the computer to overwrite the value, put a new value in the box. So from this point forward, whenever I ask the computer to work with X, now it has a 12 inside of it. You can make variables constants so that the values inside of it cannot be changed or overwritten. But unless you use that special reserved word to do that, then it's just going to be a variable that can be overwritten. Okay. I talked about data types earlier. I mentioned that the computer might need to know what kind of information you have stored inside of your variable. We have 4 different data types that we're going to be working with in Python. So we have int, which is short for integer, and that's going to be just like it is in math. An integer is just a whole number. Can be positive or negative, but a whole number. We have a float, which is a number with a decimal. And then str is short for string. I've already mentioned that one a few times in the video. So a string can be any text, and we do put it inside quotes. And then bool is short for Boolean, which was the mathematician's name who kind of came up with all of these logic concepts that we have for writing true false logic statements. So a Boolean value is either true or false, and that gets stored in the computer as a 1 or a 0. So 1 would be true, 0 would be false. And Python kind of has this neat ability that because it can dynamically tell what data type you want to work with. So like see in this example, I did not tell the computer that I wanted X to be an int. I didn't say that. Is. In a lot of other programming languages, we would have to tell the computer, like in C++ or Java, we would have to tell the computer, I want you to make a variable called X, and it needs to be able to store whole numbers. And then we could go through and put this 42 in here. But this isn't really the way that Python works. When I try to do it like this, it kind of says this is invalid syntax. We don't have to tell it the data type that it's going to be. If I just give the computer a whole number, it is going to make that variable hold whole numbers. It does it for me dynamically, automatically, on its own. So that's another one of the things that makes Python a really kind of nice language to work with. How could I tell what data type this is? I mean, we could just look at it and see that it's whole numbers and know that that's what it must be. But Python has this built-in command called type. So what type is telling the computer is saying, what is the data type of whatever variable we put here inside these parentheses. So I'm saying, what is the data type of X? And then I ask the computer to print out that result so I can see it on the screen. So when I run this, it's telling me X is an int, which is perfect. That makes sense to us because we stored a whole number in there. I could create some other variable like name equals Micah. And then if I ask the computer, what is the data type of the variable name, that's a string, right? Micah is a series of text. This is like a set of text. So this is a string. And I didn't have to say that as the programmer. The computer figured it out on its own, just automatically, which is really nice. Okay. Let's see an example of a float. I haven't done any floats yet. I've been doing a lot of work with just whole numbers and strings, which is great, but that's not the only way that you could do things. We could say like num1 equals 2.5, and we could say num2 equals negative 8 point, I don't I don't know, point four. Sure. And then I could do something with that. And in just a second, we're going to see like some mathematical operations we could go through and do it with that. So what if I just ask the computer, what is num1 plus num2? And it would go through and actually do that operation and print out the result for me, which is nice. Okay. What would a bool look like? That was the other data type in our slides. So a bool is some true or false value. So for example, I could create some data type, like I could say choice, and I could just, specifically say it is true or it is false. And we later next week, we'll talk about conditionals, how we can get the computer to make decisions and go down different paths based on whether or not something is true. And we'll use bools a lot then. So, for example, if I ask the computer, what is the data type of this variable choice, the computer knows that that is a bool data type because it has a true false value stored inside of it. Python does capitalize the T in true and the F in false. Most languages do not. So note that we do capitalize those Boolean values. So here is where we're going to do a little bit of math, and there are 2 or 3 mathematical questions on quiz 1. So I am going to spend some time here going through some examples of these. So the operators are going to be the special symbols that allow us to do mathematical operations. So we've got addition, subtraction, multiplication, division, and then in Python, if we have 2 asterisks together, that's going to say exponent. So take a number raised to the power of this second number. And then we have to give it something to actually operate on. We have to give it the operands. We could just type those in. They could be just hard-coded numbers. They could also be variables. We can do math with variables. And then we're going to introduce 2 new operations that you might not have ever seen before. And this is where I'm going to just pull up Paint and we're going to just go through and do a couple of examples with this. So the first one is represented by a percent sign, and it's called modulus. Sometimes people will call it modulo, and sometimes people will just call it mod, just for short. So what people mean when they say modulus is they want you to take the two numbers given, divide them, and instead of returning the quotient, which is that's like the answer to a division problem, that would be the answer we would normally give when we divide. Instead, I want to know the remainder. What was the leftover part when you divided out these two numbers? So let's take a look at what that might be, what that might look like. So let's say, for example, I asked you to we'll do an easy one. What is 5 mod 2? So what I am asking you to do is take 5 divided by 2. So let's give ourselves a little room here. So I'm going to do 5 divided by 2. So I say, how many times can 2 go into 5? Twice. 2 times 2 is 4. What is the remainder? 1. This down here, this 1, that is my answer. This quotient up here, this answer to the division problem, nobody cares about it. Just forget it. 5 mod 2 equals 1. So kind of just take a second and think what that could potentially tell you about a number. Like if you could go through and divide any number by 2, what would the remainder potentially tell you? And I'll kind of give you a hint here. I'll do another example. So let's do an example of 6 mod 2. So here I have 6 divided by 2. 2 goes into 6 3 times. 2 times 3 is 6. The remainder is 0. The remainder is the part that I care about, not the quotient. So these are my answers right here. I'm just going to use the little type, and we're just going to type here. So we have 5 mod 2 equals 1. And we have 6 mod 2 equals 0. What could you potentially tell or figure out about any given number by using the mod 2 operator? You can determine whether or not the number is even or odd, right? If I can divide a number by 2 and there's no remainder, what that means is the number was evenly divisible by 2. It's an even number. If I divide the number by 2 and there is a remainder, it was an odd number, right? So that's just kind of one small application. And there are a couple of examples here. So I'm going to draw a really big rectangle to just kind of erase everything that's on that screen. So let's just make it all white and just kind of, did I lose it? I just want to erase this all. What is it? Why is it not filling in? Because I'm telling it no fill. That's why. All right. So let's just fill that all in. Just have a clean slate here. So I'm going to put just an example here on my screen. And then I want you to just pause the video and try working it out yourself on like a piece of paper. So let's do 10 mod 4. Go ahead and try that one yourself. So I'm going to do 10 divided by 4. 4 can go into 10 twice. Ah, this was not a good example because the remainder and the quotient were the same number. So I should not have chosen that one. But hopefully you got the number two, whether you did it correctly or not. I'm going to give you one more example before we move on. Click off of that. I want you to try 5 mod 8. 5 mod 8. So here I am taking the number 5 and I am dividing it by 8. How many times does 8 go into 5? It doesn't. 8 is bigger than 5, so it would go in there 0 times. 0 times 8 is 0. My remainder is 5. So this equals 5. If you said that it was 3, you probably swapped your numbers and you just kind of made it 8 mod 5 instead. A rule to know about the modulus operator is that whenever you take a smaller number and you mod it by a bigger number, it's always just going to return that smaller number back out, right? Okay. And then our second big thing to know, so there's a lot of math on this slide, and I do want you to know it because there are a couple of examples of it. And actually, math is going to be a big part of our first program too. So I do want to spend some time going through these. The other new command that we're going to have for Python is going to be, so just this one single forward slash is division. But in Python, when I have 2 forward slashes, I'm telling the computer to do integer division. And remember, an integer is a whole number. So what I'm telling the computer is I am working with integers. I want an integer result. So even if the real answer to that quotient should have an integer, if it should have some decimal portion, it doesn't matter. When you're doing integer division, the computer is just going to truncate that answer. So let's say, for example, 5, is it a 4? I think it's forward. Yeah. 5 divided by 2. But note that because I have the 2 slashes, I'm doing integer division. So if I say, what is 5 divided by 2? And I get the 2, I'm done. We're finished. This equals 2. In reality, 5 divided by 2 should be 2.5. I would have to actually keep going and do the division and find the decimal part of it. We are not going to do that with integer division. It does not round. It does not look at the decimal and then see if it needs to round up. It does not even calculate the decimal portion. The term that we use is truncate. It is just completely chopped off. We just disregard it. Okay. So, let's say so try this one yourself. I have 3 divided by 4, but I am doing integer division. I have the double slashes. So go ahead and try it. If you actually, did 3 divided by 4, 3 divided by 4, 3/4 is the number 0.75. but we aren't looking at the 0.75. We only care about the whole number portion. So we would just have the 0 and that's it. So if we try to kind of take a look at some of these, like in programming, like if I come back over here to Glide, and I'm going to just erase all of the code I've written so far, and I'm going to just clear my output, just have a clean slate. And I'm going to come over here to my toolbox, and I have a few of these mathematical operations, so I could just kind of see some examples here. If I just click on them, this is going to show me an example of addition, which is the plus sign, and subtraction, which is just minus. Multiplication would be the asterisk, and then division is just the one singular slash. And we could go through and predict, what that would do. 8, 6, 42, 5, like that's fine. Notice that I got 5.0 because I am keeping the decimal portion. In fact, let's change this and make it something that would not work out nicely. So see, we are getting the decimal part of that answer. It's doing a true complete division. However, if I went in there and added an integer division, oh, and you see what I just did? That is actually kind of a good thing to note. Whenever you click to insert something from the toolbox, it's going to insert it wherever your cursor is. So you need to kind of be careful that you have your cursor where you want the new code to go whenever you click it. So if I do integer division, see now I have the 2 slashes. And you can see the difference. It no longer has the decimal portion, and it did not round up to a 7. We just got the whole number, and that's it. Here's an example of that mod operator we were talking about just a second ago. So just yourself right now, think in your head, what would be the result of this? What would be 10 mod 3? And see if you can kind of get that answer yourself before we click run and see what the result is. So if I'm trying to say what is 10 mod 3, I'm saying take 10, divide it by 3. 3 can go into 10 3 times. I want the remainder, right? 3 times 3 is 9. 10 minus 9 is 1. This is my remainder down here. So if I come up here and run this code, I see, here, let's clear it all. If I come up here and run this code, I see that that remainder is 1. Exponents is where I'm taking a number raised to the power of another number. So the first number is your base, and the second number is your exponent. So I'm saying take the number 2 and raise it to the power of 3. So this would be 2 times 2 times 2, right? It would be 2 cubed. So we would say 2 times 2 is 4 times 2 is 8. Oh, and I did it again. I did not pay good attention to where my cursor was. So I'm just going to hit Control Z to undo that. And then I'll fix my cursor before I come down here and insert this next one. We won't be using increment and decrement a whole lot just yet, but we will use it very often whenever we get to loops and we start talking about going through and taking a chunk of code and making it repeat, making it go through and loop more than one time. And so here is an example of how you can do that. So this is called the combined assignment operator. I say, okay, I have the value X, it has a 1 in it. I want you to take whatever value is inside of X right now, and I want you to add this value. And then I still want you to go through and do the assignment. So I want you to add it and also I want you to take that result and put it back inside of X. So what that means is whatever number you started with, you would just add one. And so we call that incrementing. An increment is just adding one to your value. And then, I remembered to fix my cursor this time. And then related to that would be decrementing, which is take whatever value you had inside that variable and subtract one. So here we can kind of see, 2 cubed is 8, and 1 incremented, 1 plus 1 is 2. If I started with 2 and I decremented, 2 minus 1 is 1. So you can go through and just play with these. Try writing some of them yourself, run it and see what kind of output you get. Try combining them, try doing more than one operation at a time. And whenever you do that, you're going to have to follow the proper order of operations. So, if you grew up in America, you probably heard PEMDAS, which is going to be parentheses, exponents, multiplication, division, addition, subtraction. If you grew up in another country, you might have heard BODMAS, which is the same concept. You just have brackets instead of parentheses, and you have what's the O? The order instead of exponent, like you're taking something to the power of something else. Here in computer science, you might notice that I have PEMDAS instead of just regular PEMDAS because we have a new operation that we have to go back in there and account for. So my new operation is modulus. So the way it would work is you would do your parentheses first before anything else. And then you would do your exponents. And then all three of these, multiplication, modulus, and division, all three have equal precedence. So we would just read them left to right, whichever one comes first. And then addition and subtraction have equal precedence. So we would just read them left to right, whichever one comes first. So what I would recommend you do is try just typing like some of these out, just testing yourself. What would happen if I said like 3 times 2 mod 1 plus 8? And then just try doing it on your own. And can you go through and get the correct answer and then run it and see if you got it right? Okay, so if we did this, and so I'm just going to kind of minimize this so I can see it without, retyping this all. So if I came out here and said, okay, so what would I do first? If I followed PEMDAS, I don't have any parentheses inside my mathematical operation, and I don't have any exponents. I do have multiplication, and I do have modulus. So I just read those left to right. So I would do 3 times 2 first. So let's write this out over here. I have 3 times 2. And we'll go ahead and do like the computer science way to write this. I have 3 times 2 mod 1 plus 8. So let's go ahead and start with 3 times 2 is 6. Oh, what is mod 1 gonna do? It's ridiculous. What a silly example for me to have. Um, let's change that. Let's say mod 2, whatever. Let's say mod 2. Because dividing by 1 and giving yourself the remainder would be a bit silly, wouldn't it? So we have 3 times 2 is 6. And then we have 6 mod 2 which would be 0, right? It would divide evenly. There would not be any remainder. And then I would have 0 plus 8 would just give me 8. So, yay! We got it correct. I really do recommend, if you are new to programming and you've never seen this before, go ahead and spend some time playing around with some of these different operations. Try writing some yourself. Try inserting one up. That cursor got me again, didn't it? Let me Control Z. Come down here. Try going through and changing it. Try changing the numbers to, something different. Maybe do like 15, make that a 4, whatever. See if you can predict the output. Run it yourself. That would be good practice. Okay, phenomenal. That was everything for math, for our order of operations, our 2 new operations, and the symbols that are just kind of built in there. And we only have 2 slides left, and the last one is an easy one, so we're making it. All right. The last command that I want you to know for week 1 is the input command. And the input command is used to get information in from the user. It can store their information in a variable. It's used to make your programs more interactive. And then inside the command, you write your prompt. And really, I should have an example of it here in the slides. So I'm just going to make a note to myself that I'm going to add the variable naming rules to the slides. And I'm also going to add a code snippet showing input, just like giving you a command with the input in the slides as well. So let's take a look at an example. So I do have a toolbox little code snippet that you can use to insert. So here in the basics command, I have an input command, and here we have it working. So let's take a look. The word is input, and that's pretty straightforward. I am inputting information from the user. And here we see those quotes again. So I know that when I see quotes, that is exactly what's going, the text that I'm working with. So this is actually what gets printed out to the screen. And it's very confusing. This trips students up every semester. The way that input works is you do not need a print command. You write the word input, and then see you inside the input command, you write the prompt that you want to get printed out to the screen. So you don't have a second print. You just put it here inside your parentheses, and that is what gets displayed. So what this is going to do is print out your name onto the console, and then it's going to read in the user's answer, and it's going to store that answer inside of the variable name. And then we could go through and do something with it. We could, change it. We could do math with it. We could, have different things that we can go through and use that variable. So now this is much more interesting than just saying hello world or hello class or hello Micah or something that we had to hard code in. Now, whoever is running our program, we are going to ask them, what is your name? And then we read in their answer, and then take a look at this print statement. Print the exact word hello, comma, space. Print that out exactly like it is in the quotes. And then also print out whatever got stored inside of that variable. So if I go through and run this, it says enter your name. Well, my name is Micah. And it says, hello, Micah. Hey, that is so great. I could run it again. I could change my whole identity. This time I could be Leanne. And now it says, hello, Leanne. It's an interactive program. We're going to get a different result every single time we run it because whatever we type in is the result that gets displayed. It's really pretty interesting. So, input is a nice command to make your programs much more interesting because the user feels like, they are part of the code and it's interacting with them and it's doing something unique and special based on what they do as well. This is the first time that something in the slides has been big and bold and red. So hopefully that's a pretty good sign to you that this is really important. You need this for the quiz. You need this for program one. You need this for all of the rest of the Python we will do in this class for the whole rest of the semester. Well, we actually only do Python for like half of the semester, but you really need to know this. When that input command reads in that information, it is going to automatically store it as a string. So remember that I said that Python will kind of go through and dynamically choose the data type of a variable for you. And usually that's really nice and it simplifies things and it kind of just like takes one task off of the programmer's, shoulders, which is great. Unfortunately, sometimes it can choose for you wrong. So, like if I asked the computer, what type of information is being stored inside of name? And it says it's a string. And that's great. And that's wonderful because the word Micah is a string. That is a set of text. But what if I wasn't trying to get somebody's name? What if I was doing a program where I needed to do some math and instead of asking for their name, I said, enter a number. Okay, fine. So let's say that I run this and I say, enter a number. And I say the number 9. And it says, great, you entered the number 9. It's a string. But I didn't want the number 9 to be a string. I wanted the number 9 to be a number because I was going to try to do math with it. And you can't do traditional math with text data. And hopefully that, just kind of makes sense, right? If I said to you, what is house times 5? Like that doesn't make sense, right? We don't have clear instructions for what you are supposed to do for house times 5. So what we have to do when we need to enter in, like when we need to get input from the user and we don't want it to be a string, is we may have to change the data type ourselves. So, what does that mean? I want to tell the computer this whole entire thing, like what you read in, I want that whole entire thing to be stored as an integer. I want to make it an integer. So now when I read in the number 9, hey, it understands that it's an integer. So you could do it like this. The other thing you could do, maybe you feel like that's kind of messy because you've got all these parentheses going everywhere. We have an input command inside of another command. making the number an integer. Maybe that's kind of messy. What you could separate it out and you could say, I want you to take this value that is stored inside of this variable and I want you to make it a whole number. So if we run and I enter it, that is also another valid way to make this number an int. Okay. Last slide. We've kind of already talked about it. So this just says, what are comments? Comments are lines of code for the benefit of the programmer. They are ignored by the computer. A hashtag makes a single line. So we kind of saw an example of this already where, a hashtag creates just a single line comment. You can also do like a block comment. So like more than one line in Python, you can do just three quotes in a row or three apostrophes in a row. And that's going to make a doc string, which can be used like a block comment if you didn't want to have to go through and do the hashtag in front of like every single line. And comments are color coded in most environments. Whenever you write your first program, and if we, pull that up and go take a look at those programming instructions, whenever you write your first program, so let's just do either one of the online sections. It has in here that, whenever you do this, let's open up the instructions. It tells you that kind of this like program documentation that you should have a heading comment block at the top of your program where you put your name, your course, and just a little description of like what your program does. So you could go in and do that, kind of like just with single lines. So you could say, your name and the class, so like CMPS 1023. And you could say, this program, blah, blah, blah. That's it. Or even if you wanted to say like program one, that would be perfectly fine. That would be your heading. So here in the instructions, the grading rubric tells you that it's worth 15% that you have your program documentation. This is that documentation. Do you have a heading up at the top? And do you have some comments throughout your code that explain like what you did or why you did it, right? And those don't feel as necessary, with these beginning kind of early programs, which are like small and simple. It's just a good habit to get in because the larger and more complicated that your program gets, the more important good comments become. So you kind of just get in the hang of doing it now. Okay, so what is this first program that you're supposed to write? Write a program that will plan a rideshare trip based on the number of passengers. Ask the user how many people need a ride. A maximum of 4 people can ride in one car. Calculate and print out how many cars will be full and how many people will ride in the last car. So here's an example. How many passengers need a ride? And then the user entered 14. And then it says 4. So then they had to kind of input the user's answer right here. So that's kind of like that example that we saw, with like this input where we embedded the user's answer inside of our output. Okay. So that's how you could do that. So you would say like for their answer number of passengers, you would need 3 full cars. Why? Because full cars can hold 4 people each. So 3 full cars can hold 12 people. Okay, so if you've got 14 people, then you need 3 full cars. And then there will be 2 people left over to ride in the last one. So, a couple of things that you would need for this program. Hopefully, it's kind of clear to you that you're going to need an input command, right? We're going to get some information from the user. I'm going to ask the user how many people need a ride, and I'm going to read in their answer. And then I'm going to have to do a little bit of math. We're going to use some of those mathematical operations. So remember that big kind of red thing. If I want to be able to do math, with information that I got from input, I need to tell the computer, hey, make these numbers so I can do math with them. And then try to think, how can you go through and figure out how many full cars you need? And then how can you go through and figure out how many people are left over? So go ahead and take a look at the grading rubric. You have a week to write this program. If you're really struggling with it, by all means, um, go see like the computer science tutors that are available in Bolin. Go to the TASP Center and get help from the tutors in the library or email me. Come to my office hours. I have office hours in person. I can also meet with you online. If you email me, we could do a Zoom call. I would be very happy to help you get set up and started with this first program. Okay. And then we do also have a quiz over these Python basics. So if we come in here and take a look at this Python basics quiz, it tells you exactly what you need to do for it. So you want to kind of know what are the rules for valid variable names. So I'm going to give you some names and ask you like, are they okay or not? Remember how reading and user input works. You want to know that input command. That's a big one because we're using it in our program. And then I could give you some mathematical expressions and ask you to figure out the answer. And those could include integer division, and those could include the modulus operator. So, definitely things that are important in program 1 are going to come up and you will see them on the quiz. So I would recommend maybe trying to write your program first. Some of that experience that you get from going through and doing that will be good information to help you be prepared for the quiz as well. All right, please email me if you have any questions. Good luck. If you want to use this environment that I made, this is linked in the slides. So when I went through and talked about all of the programming environments, it's linked right there. You're free to use it. You do not have to at all. You are welcome to use any of these other programming environments as well, whatever you are comfortable with. I hope you have a great week, and I will see you next week when we will start talking about conditionals and we'll introduce loops. See you then.